All right, welcome back to geometry. Last time we had met, we were talking about circles and the angles inside of circles, and we looked at two types of angles last time. We looked at central angles, which had the vertex in the center of the circle, and we looked at inscribed angles, which had the vertex on the outside or the edge of the circle. So we're going to talk about a new type of angle that can come up in circles today called outside angles. But in order to sort of jump into this, we want to go over two definitions really quick. They're not super important for outside angles, but we do use them, and they will come important later on as we progress throughout our circle unit. So I have three pictures right here. I have a tangent line, a tangent line, and a not a tangent line. So based off these three images, what can you assume a tangent line is? Well, if you look at these two tangent lines, we see that they both cross the circle at a single intersecting point, while this not tangent line crosses it at 2 points. So it's a tangent line. It's a line that specifically touches the circle only once. It comes towards the circle, and then it hits it just at a single spot and then sort of bounces and keeps going. So it touches just at the edge of the circle and then keeps going. It doesn't pass through the center of the circle or through any part of the circle. It just hits the edge and keeps going. So that's our tangent line. It hits the circle once. Now, the other type of line we want to talk about is a secant line. So I have a couple examples of secant lines. So I have a secant line, not a secant line, and not a secant line. So what does it look for a secant line? Well, a secant line, as you can probably see, a secant line touches twice. It doesn't necessarily matter exactly where it touches on the circle, as long as it touches twice. The secant line, though, does not pass through the center of the circle. Because if it passes through the center of the circle, then that would be a diameter of our circle, which is a little bit different from a secant line. This obviously is not a secant line because, as we can see, it only touches the circle once, so that would make it a tangent line. So we know this is a tangent. And then this is not a secant line because it doesn't pass your circle. It doesn't touch your circle at all. So whenever we cross the circle twice, whenever we touch the circle twice at each edge, that's a secant line. Whenever we touch the circle once, that's a tangent line. Now, we can use these types of lines, secant lines and tangent lines, to make up special types of angles that show up in our circles. And we can use this information to help us solve for some of those different angles that we'll see. Now, tangent is similar to sine, cosine, tangent. So that it's the same word. Not necessarily, they don't necessarily relate. A little bit in pre-calculus, we'll talk about how they relate a little bit. But for right now, they kind of represent two different things. There's a tangent line, and then there's our tangent trig ratio. But it's same word, but they don't really represent anything similar at the moment for geometry. All right. So recapping. So once again, we talked about central angles and inscribed angles. We talked about central angles, once again, having the vertex in the center. Now, a central angle was always equal to its intercepted arc. So the intercepted arc, this dashed line right here in blue, is going to be the same degrees as my central angle. So if it's 80, it's 80. Our other angle was an inscribed angle. Inscribed angles had the vertex on the outside or on the edge of my circle. And we know that their intercepted arc is always 2 times the value of the angle. So if I have 80 times 2 gives me 160 degrees, and that's going to be my intercepted arc. So it's always double or half, depending on which way you're going, whether it's your intercepted arc to the inscribed angle or inscribed angle to the intercepted arc. It's always twice the value. So those are what we talked about. Now we're going to jump into outside angles. So outside angles are pretty straightforward. It's an angle on the outside of my circle. So looking at this, I have my angle on the outside is 50 degrees. This first inscribed arc is 80, and this outside arc is 180. I have an inscribed angle, I have an outside angle of 80. My arc 1, or my inside arc, my minor arc, is 100. My major arc is 260. I have an inside or outside angle of 50. My minor arc is 50. My outside arc is 150. Do you notice any patterns that appear to be showing up with these outside angles? So looking at it, you might be able to pick up. It's not necessarily as obvious as some of our other patterns, but you might be able to pick up that if I take 180 minus 80, that leaves me with 100. And 100 divided by 2 equals 50. If I take 260 minus 100, that leaves me with 160. And then if I take 160 divided by 2, that leaves me with 80. And if I take 150 minus 50, that leaves me with 100. And then once again, 100 divided by 2 equals 50. So we do have a pattern that shows up with these outside angles. It's always the major arc minus the minor arc divided by 2 will equal your outside angle. So your big arc minus your little arc, whatever that difference is, divided by 2, that will always equal your outside angle. And so we can use this pattern to help us solve for outside angle measures, assuming we know some of those arcs. So, okay, so if I have a major arc of 178, a minor arc of 76, and I'm looking for my outside angle, all I have to do is take 178 minus 76, and this leaves me with 102. I can then take 102 divided by 2, and this will leave me with 51 degrees for my outside angle. So x is 51. Same idea with the second one. 230 minus 130 leaves me with, once again, 100. Oh, I know 100 divided by 2 is 50. So 50 degrees is my angle. Now, what about this last one? This last one, rather than having me solve for my outside angle, it's having me solve for this larger arc. So essentially, I know that it's some number minus 84 divided by 2 equals 31. Well, I can kind of work this backwards like an equation. I can solve this for x. Well, in order to solve this, I need to get rid of my denominator. So how do I get rid of that denominator? Well, I can multiply by 2. So multiplying by 2 gets rid of my denominator, but if I do it to one side of my equation, I have to do it to my other. So I have x minus 84 equal 31 times 2 is 62. And then if I add 84, if I inverse this, essentially I'm just going through the steps backwards. I'm inversing everything. Rather than subtracting, then dividing, I'm multiplying, then adding. I'm just doing my inverse operations. And so I add 84. So I get x equals 62 plus 84 is 146. And so that is our outside arc. One way we could check this is if we take 146 minus 84, that leaves us with 62. If I divide that by 2, that gives me 31 degrees, which checks out. So I know this works because I can check it. So that's pretty easy. We can use those outside angles to help us solve for those missing pieces. All we have to do is that strategy. If I take my large arc minus my small arc, divide by 2, sometimes we have to work backwards a little bit to get those arcs, but we can still solve for them. All right, what happens if I'm solving for my middle arc, though? What happens if I'm solving for that minor arc? Once again, we can kind of set up like a fraction, or we can kind of set up like an equation to solve. I have 146 minus x divided by 2 equals 33. I know my large arc minus my small arc divided by 2 equals my angle. Well, once again, in order to solve this, all I need to do is first get rid of the denominator of my fraction. So in order to get rid of division, I multiply. So I'm dividing by 2, I'm multiplying by 2. And those will cancel out. So that'll leave me with 146 minus x, sorry, not 6, minus x, equals 33 times 2, which 33 times 2 is 66. And now, once again, I'm solving for x. So in order to get x, I can subtract 146 to get x all by itself. So this gives me negative x, because I still have that negative sign in front of it, equals 166 minus, or 66 minus 146 is negative 80. Well, I have negative x equals negative 80. In order to get rid of that negative sign, I can just divide by negative 1, and those will cancel out because this is essentially a negative 1 in front of my x. Well, what's negative 80 divided by negative 1? It's just going to give me positive 80. Because anything divided by 1 is itself, so negative divided by negative is going to give me a positive. So positive 80 is my angle. Once again, I could check. 146 minus 80 is 66. Divided by 2 is 33, so it works out. So we know it works. All right, on this one's a little weird. They only gave me one angle. They only gave me, and actually they didn't even give me any of the arcs. They gave me the central angle of 135. But luckily, I remember thinking back to our last lesson that central angles are actually equal to their arc, their intercepted arc. So if this is 135, that means this angle here also has to be 135. Well, looking at these are two tangent lines. And so that means my tangent line touches my circle right here, and my tangent line touches my circle right here. So in total, I know this entire circle is 360. Well, if I have a minor arc of 135, I know in order to find my major arc, all I have to do is 360 minus 135. Let's see if I can remember what this should give me. 225. So 225 is going to be our major arc. 135 is our minor arc. With this, now we have enough information to solve. All we have to do is 225 minus 135, and then divide whatever this answer is by 2. So 225 divided by 135 gives me, is that 90? And then 90 divided by 2 equals 45. So my angle should be 45 degrees. It's possible I might have messed up there because I'm doing some mental math, but if I apologize if I did it. You know what the idea is. Similar idea. Once again, they gave us my central angle of 120. So I know this right here is 120, which makes my outside angle 360 minus my 120 should give me 240. So this is 240. So all I have to do is 240, my major arc minus my minor arc of 120 divided by 2. Well, 240 divided by 120 is 120 because 240 is doubled. 240 minus 120 is 120. Divided by 2 is 60 degrees. So 60 degrees is our final solution. All right. Moving on. All right. What is the value of x? So in this one, they're giving us a little bit of a hard time. They threw in some expressions here rather than giving us some angles. So what they told us is we have a major arc of 3x minus 2. A minor arc of x plus 6, and then they gave us an angle, an outside angle of 34, and they're telling us to solve for x. Once again, whenever I'm solving something like this, it's probably easiest just to set it up like an equation and then allow me to solve for x in that way. If I don't know how to go for it, just use our pattern to set up as an equation, and then let's try to figure out if we can solve it from there. So I know it's my major arc of 3x minus 2 minus my minor arc of x plus 6 divided by 2 equals my outside angle of 34 degrees. Okay, I think I can do this. Once again, we know whenever we're trying to solve these types of equations, it's probably easiest just to get rid of that denominator first. And having to work with this denominator is not a lot of fun. I don't want to have that fraction here. So I'm going to get rid of that denominator first. So I'm going to multiply by 2 to get rid of my denominator. But if I multiply one side of my problem by 2, I have to multiply the other side of my problem by 2. So this is going to leave me with 3x minus 2 minus x plus 6 equals 34 times 2 is 68. All right. So now we're on to something. This over here is kind of a mess, but I can simplify this. I can combine my like terms. But in order to combine like terms, I need to get rid of those parentheses. And that means I have to distribute. So I have to take this negative out here. I have to distribute this negative because it's technically a negative 1. I have to distribute this negative 1 to each term inside those parentheses. So this is going to be, and there's a 1 out here. So if I distribute 1, it's not going to change. So that's going to be 3x minus 2 still. But negative 1 is going to turn this into negative x. And negative 1 is going to turn this into negative 6. So I have 3x minus 2 minus x minus 6 equals 68. Now we can combine like terms. So what like terms do I have? Well, I have a 3x and a negative x. That's going to give me just 2x. And then I have a negative 2 and a negative 6. If I combine those two together, negative 2 minus 6 is going to give me negative 8. And this is going to equal 68. Well, now we're at that two-step equation. Now we know how to easily solve this. It's just 2 steps. Inverse my constant, inverse my coefficient. So I can add 8 by inversing my constant. So 68 plus 8 is going to give me 76 equals 2x. If I inverse my coefficient, divide by 2, that gives me 76 divided by 2 is x equals 38. And that is going to be our solution. If we really wanted to check this, what we could do is we could plug x back into our equation, and we could say, okay, if x is 38, and then 38 plus 6 would make this 44. It would be 38 times 3 is a number. That's 118. No. That's 114. I apologize. Minus 2 is 112. So what we could do is do 112 minus 44 divided by 2 and check to make sure that's 34, which it should be. But it's possible I've made some mistakes with my mental math. I apologize once again if I did. All right, so let's recap everything. So we have 3 types of circle angles. We have central angles, which we know are equal to their intercepted arc. So if this is 100, that means my x is 100. We have inscribed angles, which we know are always half of our intercepted arc. So if my arc is 100, that means my angle is 50. And then lastly, what we talked about today is we have outside angles. And outside angles are always equal to their major arc minus the minor arc divided by 2. So 260 divided by, or minus 100 is 160, divided by 2 is 80 degrees. So those are our 3 types of angles that we know so far. We'll add one final type of angle in next time, and that is where we will end it for today. You're going to have some practice over some outside angles and a little bit of review over all of these angles, and then a little bit of spiraling today as well. There should be an exoslip on Schoology as well. Let me know if you have any questions.